Hi, this is Jenny Baldwin, and I was going to go over some of these lessons that were not mastered by Chase. There are 9 that show up on his plan that weren't mastered, and so we are going to go through each lesson checkpoint and just look at them so that you can see. The most important thing, though, if you're just skipping through the lesson checkpoint, or maybe you've taken this assessment 2 or 3 times, it means that just taking the lesson checkpoint one more time may not be all that is needed. You may need to go back and review the lesson and the teacher guide itself. So always make sure you're clicking on the first tab initially. So um, this one right here that said prime numbers less than 100 was one that needed to be mastered. And so it is important to kind of go through, and you can go through the student activity book as well. And I'm going to just simply click continue. This is not his account. This is a account, just a generic account. So I'm going to look right here, and at first it says review assessment. Now, before you ever retake an assessment, I always want you to click on review assessment so you can see what you missed. And it's going to go through and tell you exactly what you missed. So it'll say if you got it correct or incorrect, so you can learn from your mistakes first before you answer it again. Now, we're going to go through, and these aren't exactly the same type of problems that you're going to see, but we're going to walk through problems just like the ones that you may see. So I'm going to open up my document camera so that I can work it out with you. But here it says, which number is a factor of 24 and also a prime number? So factors are basically the multiplication facts. So if I have the number 24, I want to think about all of the multiplication facts that make 24. Sometimes I think it's fun to make a factor rainbow. I know that 1 times 24 is 24, and I know that 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. And you can see how they each have a partner on each end of the rainbow. So these are all factors. So when it says to select all the factors, that's what a factor is. But then the second word says prime. It says we want a factor that's also a prime number. Prime and composite are 2 terms that you'll hear a lot about. Prime are numbers like 1, 2, 3, 5, 7, 11, 13. You'll see that prime numbers can't be divided and have a lot of factors like 24. 24 has 1, 2, 3, 4, 5, 6, 7, 8 different factors. But a prime number only has a factor of 1 in itself. So which of these would be one of these prime factors? And it says is also a prime factor. So our choices are 3, 4, 8, or 12. So if we look at the screen, we have 3, 4, 8, or 12. The answer would be 3. And the reason this is prime is if I did the factor rainbow, there would be no numbers in between here. It's just the 1 and the 3. The same is true for 1 and 2. But if I did the number 4, I could have 1 and 4 and 2 times 2. So there are more than just the number 1 and the number itself. 3 is prime because it's the number 1 and times itself. So 1 times 3 is 3, and that's all it is. Think about composite means it's composed of many factors, just like 24 has many factors. So let's move on to the next example. And on number 2, it says, which number is a prime number? Now again, what we're going to do is think about what number is prime. And I think of like monkeys are primitive, they're primates, um, they're not like us. We're kind of more advanced than a monkey. So a monkey is more prime than we are. So which one of those numbers, 18, 31, 39, 42, cannot be divided up? it only is 1 times the number itself. Well, I know that 31 can only, there are no factors, like 2 won't go into 31 evenly, 5 won't go, 3 won't go. But if I take the number 39, and sometimes you may have to use counters, like I think it would be very helpful if you want to figure out if something is prime. Definitely decide if it's an even number. Both of these aren't even, so we know 2 won't go into it, but you could easily draw 39 counters. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I could have 39, and you could use blocks at home to do this, and you could learn how to use your scratch paper to do this. But if I could divide it in any other way besides just one whole group of 39, like I could do 3 and 3 and 3, and we'll see if there's any left over. And there's not. So that means I could divide it by 3, and 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 times 13 are also factors. They can be multiplied together to get 39. So that's why I know that 39 is not prime, but 31 is prime because it can't be divided by 2, 3, 4, 5, any of those other numbers. So now let's look at the next question. So prime basically means there is nothing that can be divided into it besides the number 1 and itself. So there's one group. So which of these numbers is prime? 14, 17, 21, 27. Well, I know that 2 times 7 is 14. So that's a composite number. There's other factors. I know that 3 times 7 is 21. I know 3 times 9 is 27, but there are no multiplication facts that equal 17. It's just 1 times 17. So 17 would be the prime factor. Which number between 6 and 10 is a prime number? So let's list all those numbers. If we, let me get my document camera back over. If we have 6, 7, 8, 9, 10, and it says which numbers between 6 and 10. So one of those numbers cannot be divided by anything except 1 in itself, and that would be number 7, because 8 could be 4 times 2 or 8 times 1. 9 could be 3 times 3 or 9 times 1. So there's more than one. There's multiple ways to make this number, but 7, there's only 1 times 7. That's it. So that's why 7 is prime. And then one last example for prime. It says, and this one is a little bit of matching, and so you may have something like this. It says match each number from column A to column B. So remember, prime is only the number 1 times itself, and that's all you can do. Composite means there's other ways to divide it up. If there's an even number, you automatically know that it's going to be composite, except for number 2 because it's so small. It is just 2 times 1. So these others, I know that 5 times 9 is 45, so I know that one's composite. Again, I would use counters and divide these up. I know that they can't divide evenly by 5 because when we skip count by 5s, we have 0, 5, 10. Everything ends with the 0 or a 5, and these don't. So I would definitely, get out counters and determine which ones are prime and which ones are composite. So hopefully that will help you on that assessment. And this one was the one with prime numbers less than 100. Oops, I didn't mean to draw on that. So now let's go ahead and we'll move on to lesson 5 or unit 5, lesson 15, and it says the core focus. So again, it's very, very important that when you go to these units, so it's unit 5, lesson 15. And we'll scroll down. Fractions can be a little tricky at times, and so if this lesson is complicated, I would definitely make sure you go through the lesson components first. Don't just skip to the test without the teaching part. So let's retake the assessment, and I'm going to open up my document camera again, and we'll work through problems like this. So this one says, Gretchen and Lena shared a pan of pizza. Gretchen ate 1/2 of the lasagna. Lena ate 2/8 of the lasagna. What statement is true? Gretchen ate less lasagna than Lena did. Lena ate less lasagna than Gretchen did. Or Gretchen and Lena ate an equal amount of lasagna. When you're comparing fractions, I think it's very helpful to draw a number line. Now remember, they have to be the same size, because if we have to compare things that are the same size. It would be like comparing a king size Hershey bar to a mini Hershey bar, and you can't really do that. So let's say that this is Gretchen at the top and this is Lena down here. And it says that Lena ate 1/2. So let's make our end point and starting point. Well, Gretchen ate 1/2, so I'm going to put that right in the middle. And we'll shade in that this is how much Gretchen ate. And then it says that Lena ate 2/8. That 8 lets me know that this has to be divided into 8 equal parts. So we have 1, 2, 3, 4, 5, 6, 7, 8. She ate 2 of the 8s. So see, we have 1, 2, 3, 4, 5, 6, 7, 8. So she ate this much. Well, that lets us know that the person that ate the most is Gretchen. So the answer would be B. Lena ate less lasagna than Gretchen did. So now let's look at number 2. And again, it looks like we are possibly comparing. So let's see. A hiking trail is 1 mile long. There are green markers every 1/10 of a mile on the trail. And there are red markers every 1/5 of a mile on the trail. Which statements are true? So let's first of all go ahead, before we even look at the answers, here's our trail, and again I'm going to do a number line, and here's my starting point and my end point, and it says there are green markers every 1/10. So let's me divide this into 10 spaces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it says there are green markers every 1/10. So I'm going to put a little green dot every single 1/10. And then it says there are red markers every 1/5 of the mile. Now, if we are thinking about 1/5, those increments are going to be a little bit larger than 1/10, because 10, they're divided into really small increments. But if I drew another number line right here, the same size, and I divide this one into fifths, it's going to be like 1, 2, 3, 4, 5. You see the spaces are bigger. So I would have 1, 2, 3, 4, 5, because these are all at 1/5, and we have 2/5, 3/5, 4/5, and then the whole thing would be 5/5. So the questions are: the last green marker is further from the finish line than the last red marker. Well, you can see they're exactly on the same place, so that's not true. The trail has fewer red markers than green markers. Yes, because they are the fifths. It doesn't take as many fifths, so that one would be true. So that would be 1. And this is where it gets tricky. It says choose all that apply. So there's going to be possibly more than one correct answer. The third red marker is more than 1/2. So let's look. The third red marker right here is more than 1/2, and that is true, because 1/2 would be right there, and so yes, that one was true too. And then it says the third green marker is less than 1/5, and no, it is not less than 1/5, because it's over here, it's greater than. So B and C would be the correct answers. Now let's look at number 3. And it says, Damon has $30, Noah has $25. Each boy donates 1/5 of his money to a charity. What statement is true? So if we're thinking about dividing this money into groups of 5, because 1/5 lets me know that denominator means that there's groups of 5. So I'm going to put $5 bills. So let's say we have 5, 10, 15, 20. 25, 30. So that would be Damon's amount. And then Noah has 25, 5, 10, 15, 20, 25. So the next question says, each boy donates 1/5 of his money to a charity. So one of the five would be this one, a $5 bill. And then we have Dylan, and it says donate one of the five. And there's six, so that gets a little bit trickier. But when he donates, he's going to have to take a whole five and then a little bit of another group to make it exactly a fifth, because we would have one and a little bit, one and a little bit on all of those. So it said Noah donated less money, and that would be true because he didn't have as much money to give. 1/5 of his amount is less than 1/5 of that amount. And then it says which fraction is less than 4/5. And this is where drawing that number line is really important. So you can just simply have a number line, and you can have your starting point and your end point. And we want to compare, we want 4/5. So let's divide this into 5 equal spaces. 1, 2, 3, 4. And I know they're not perfect, but you do want to make them as even as possible so you won't mess up. Then we have 8/10. Well, if I have a number line with 10 spaces, it would look more like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8/10 would be here. 4/5 would be here. Very, very close. 5/5 would be the entire thing, because 5/5 means the whole thing. So 4/5 is definitely less than 5/5. And so there you go. The answer is already settled. And 3/10 would be down here, like at the bottom of the number line. And 9/10 would be here. So it's easy to tell that 5/5 is more than 4/5. Well, it says less than, I'm sorry. So it'd be 3/10. I read the problem wrong. Which number is less than? So that would be 3/10, which would be way down here. And 4/5 is up here. So this one is definitely less. So the answer would be 3/10. Okay, and last example for this one. Linda spent 2/5 of Monday working on a school project. Angela spent 4/10 of Monday working on a school project. Which statement is true? This is where you need to draw those number lines and really think about those increments. 4/10 and 2/5 are equivalent fractions. That means they mean the same thing. And there's a reason that I know that. So if I have 4/10 and I have 2/5, I know that both of these numbers are even numbers, and I again could draw it on a number line and really show that they are the exact same. But 4/10 and can be simplified because I can divide the numerator and the denominator by 2 and get 2/5. And you can see that 2/5 is the same as 2/5. So the answer would be that Linda and Angela spent the same amount of time. So now let's look at the next problem. It looks like we're moving on to Unit 3, Lesson 4 on the distributive property. And I see that this one was only taken one time, and this one is fine to go over, but it is probably worded a little advanced, but I think once we go through this, you'll understand. So I'm going to click on the lesson checkpoint, but remember the lesson, you don't just go to the lesson checkpoint. You need to go through all the components of the lesson and the workbook as well. So let's begin the assessment to go over some of these problems. Now, before you begin, review the questions that you've already answered and find out which ones you missed so that you won't make those same mistakes again. So you can always review. Now, in this problem, and this is the one that you mentioned on the phone, something similar, it says 4 times 8 minus 3 equals 4 times 8 minus blank times 3. Now this problem is showing the distributive property. That's what this whole lesson is about. And when you distribute something, we're going to multiply this 4 times the 8, and we're going to multiply this 4 times the 3. So basically all they've done is show that you have 4 times 8 here, and then what would go in the box would be 4 times 3, because we are multiplying both. Now if we did it this way, I know the orders of operations can get really tricky. They're not wanting you to solve the problem, they're just wanting you to understand that this 4 is technically multiplied by both numbers. So if we said 4 times 8, that would be 32. Take away 4 times 3 would be 12. And if I subtracted, I would get 20. Now let's see what happens if we subtract first. And we would have 4 times 5, which equals 20. 20 equals 20. Both sides are the same. So all we did was fill in that empty blank, showing that this 4 is multiplied by both. And so I hope that helps with that problem and just understanding it a little bit more. The next one is basically the same type of problem, except there isn't a space, or there's no parentheses on the second half. But they're basically wanting you to multiply that 7 times both numbers. So we have 7 times 3 plus 9. So on the other side, they already have 21, but what is the other number? Well, 7 times 3 is 21. 7 times 9 is 63. So the answer would be B. You're basically, like I said, multiplying that 7 times both numbers within the parentheses. We're distributing it across. Okay, here is a more complicated one. Now this one is kind of enrichment, but I can help you be successful with this. We have 12 times 7 plus 12 times 5 equals C. There's not just a fill in the blank, they're wanting you to solve the entire thing. So I know that the 12's timetables can get tricky, so just work those out in your head. We know that 12 times 5 is 60, so that gives us a clue, and we can always kind of decompose and say, I know that that's a 5 plus a 2, so 60 would be 5 times 12, and then if I had 5 times 2, that would be 2 more. 5 times 2 is, 12 times 5 is 60. 12 times 2 is 12. When I add 60 plus 12, I get 72. So I'm able to add those together and get one more group. Let me see if I just did that right. Oh, that should be a 24. Sorry, it's 12 times 24. I was thinking 6. So it'd be 84. So 84 plus 60, we would add those together, and that would be your final answer. So basically, you're multiplying and then adding it together. Okay, so let's look at another one. This time we're matching a problem we're matching a word problem with this. So it says Flora has 22 vases. Each vase has 6 tulips and 9 carnations. Which expressions correctly show how to find the total number? So each vase has this amount in it. So we can multiply 22 times 6 plus 9, or we could distribute it out, and we could have 22 times 6 first, and then 22 times 9. And we always want to add those together. So we have one part and then add it to the second part. We don't ever want that multiplication sign in between, and we don't want an addition sign here because we're multiplying. 22 vases each have this many in it. And then the last one says, the volunteers created 21 snack kits for the camping trip. Each kit has 5 granola bars and 4 bananas. So you could write that up. There are 21 snack kits for the camping trip, and each kit has 5 granola bars and 4 bananas. So you could just do this first and say 21 times 9 if you want to, or you could do 21 times 5 and then 21 times 4 to get the final answer. So hopefully that will help you be successful with the distributive property. Now let's take a look again. Let's head back to Unit 2, and it says Unit 2, Lesson 2, Estimate to Solve Problems. And I noticed this one was taken quite a bit of times. It was already taken 4 times. So let's check out Unit 2, Estimate to Solve Problems, and we'll take a closer look at that to see what types of questions are being asked within that unit. So I'm going to, remember, you can view your attempts and look at the ones that were mastered and not mastered. So before you open it up again, since you've already done it 4 times, go over all the problems and see where you may have made those mistakes. So once this opens, we'll talk through a few of these. Estimating means that we're going to not get the exact answer. We're going to round to a friendly number and see if we can estimate and get close. So as we go through, let's click on question number 1. It says, which numbers can best be used to estimate? So these are awfully large numbers, but we could estimate and make this one round to 630,400 and get rid of that 29, as well as round this one to 27,800. Now, you are not likely to see questions this advanced. The reason this one is definitely the choices because we wouldn't round up to 9 on this. This one also wouldn't round up to 500. So these two are the only options that would match. On this one, it says, what is the best estimate for the sum? Now, if I look at my answer choices, it looks like they did round to the nearest at least 100 or 1,000 on all of them. So if I round to the nearest 1,000, use those answer choices as a guide. I'm going to say 31,000 plus 59,000. And the reason I made it a 59,000 is because 58,700 is closer to 59,000. So when I add those together, that's a 10. I have 8 and 9. So it would be 90,000. So I'm going to just answer one more in this section. But we definitely want to make them friendly numbers that are easier to add. So when we look at this one, it says Burgertown earned 7,200 on Saturday and 5,874 on Sunday. Now look at these answer choices. There are some hundreds in here, so I'm thinking we're going to round to the nearest 100. So 7,200 plus 5,900, because that 8 would become a 9 because we need to round up. And when I add them together, I get 0, 0, 11, 12, 13,100. So hopefully that will help you on that unit. So now we are already down to using boundary numbers for rounding. And this one you might want to do before you do this estimate to solve, since it does involve rounding and knowing when to round up and round down. And this is an important lesson. So let's go to Unit 1, Lesson number 7. And there are some great Guernzillian videos on rounding as well. So when we look at boundary numbers, I definitely want you to go through the entire lesson, scroll through every single page so that you'll know exactly what to do. Let's go ahead and retake the assessment, or on my end it looks like I'm retaking the assessment, and we'll check out some of these problems. It says, what is 674,921 rounded to the nearest 10,000? So that's a very large number, so let me write it down, 674,921. What you need to do is think about where the digit is that's in the 10,000, and that's a 7. So underline it on your scratch paper. Everything behind that 7 is going to turn into a 0. And when I look at this, I always want to think if the number next door is 5 or more, then we're going to round this up. But if it's 5, 4 or less, we're going to keep it the same. So this number would round to 670,000. That 7 stayed the same instead of going rounding up, and everything else turned to a 0. So let's look at the next one. It says the library in a county have a total of 235,000 books. What is the number rounded to the nearest 100,000? Now again, we have to think about what number is in the hundred thousands. 2 is in the hundred thousands. When we look next door, the number is less than 5. It's 4 or less. So everything is going to turn to 0, and that number is going to stay the same. So we have 200,000. Rounding can be pretty fun, and as long as you're able to really think about place value. So this one says we're rounding to the nearest 100. So I have 629,462. 4 is in the hundreds. If I look next door, the number is more than 5. It's beyond the middle in between. So if we round to the nearest 100, I'm going to have to go up. And so we would turn this to a 5 and then zeros, because this number right here tells me I need to go up to the next 100. Let's see what the next problem is. Kind of the very similar thing, but it says Teddy was asked to round a number to the nearest 100. He correctly wrote 27,400. Which could have Teddy round? Well, this one would round to 26,400, so that one is not it. This one would have rounded to 26,300, so that's not it. This one, though, would have rounded 27,400 because that 3 would have turned into a 4 because of that 8. And then this one says round to the nearest 1,000, so we're going to look at that 4 in the thousands and look next door. Since it's 4 or less, we're going to let this rest and stay the same, so 174,000, and the answer would be C. So we're making quite a bit of progress, and there's only a few left. Right now, they are covering fractions, or they will be covering fractions a little bit more in the OLS and Class Connect. So I'm going to hold off on these fraction lessons for a bit, and I want you to try to get these lessons and units, these original lessons taken. This lesson up here is also Unit 5. It looks like fractions are a little bit tricky, and so we will be hosting some extra sessions, and I will talk to your teacher about some things we can do for fractions. And then I will go over this one right here that's in Unit 4, Lesson 6, but we'll hold off on the Unit 5 ones for the most part. Unit 4, Lesson 6, and this is on angles and measurement and lines. And so there's a lot of vocabulary in all these geometry units and measurement units, so I think that's part of one of the trickiest things. So let's go ahead and go through, and remember, go through all of these lessons and take time to listen to the tutorials, and as well as go to the online books for everything. And right here, let's retake the assessment, and let's take a peek at what we have. It's kind of tricky because what this means is we have an angle M. So just pretend there's an M right here at this little vertex, the point, and it says angle 2 plus angle 1 equals angle 3. You can see that angle 2 is little right here. Angle 1 is really big, and angle 3 is small. So this one would not be an accurate statement because it looks like 3 plus 2 equals 1, or we could take the whole 1 and take away 2 to get 3. So let's see, it says choose all that are correct. So we could add 2 plus 3 to get 1, because the 2 little ones would make the 1 big one, or we could take the big one, take away 2 to get 3. So both of those. So remember, I think the tricky part is that we choose all. So read the question very, very carefully. It's really just adding up angles to make a bigger angle, or taking a big angle and breaking it into two smaller angles. Here we have again another one. Notice that the big angle measures 81 and there's two smaller angles inside. So if we want to figure out the value of B, we need to take the big angle and take away 50 to find out that B. So let's see. We could do it this way and say, no, we can't add 81 plus 50, not that one. We can't take away B from 50, that's not right. We could have 81 take away B to get 50, and which would, I think a better way to state it would be 81 take away 50 to get B. We have to think about those fact families. So the answer would be C. We have the big, we want to take away one of the littles to figure out the missing amount. Now, these are some of the vocabulary words. Acute means it's really small, less than 90 degrees. Obtuse is bigger than 90 degrees. A right angle is 90 degrees, and a straight line would be 180, which is straight across. So angle 1, and let's see if I can draw this as we write it down. And it says angle 1 is composed of two non-overlapping angles, 2 and 3. Okay, 2 has an angle of 135. Okay, that means it's going to be big. So this is angle 2. And it has 135 degrees inside. And then it says angle 3 is 45. So I'm going to add that here, and that would be 45. And it says angle 1, and this is angle 3. Angle 1 is composed of both of those. So angle 1 is really big. And it says, what type of angle is 1? So I'm going to add these up, 135 and 45, because my drawing may not be completely accurate because I didn't use a protractor. So I have 5 plus 5 is 10, 8, 180. 180 means I have a perfectly straight line. There's 180 degrees. So my drawing was almost right. So the answer would be straight. And then to find the missing angle, we definitely want to add angle 2 together plus 3 to find the missing number here, because we have part whole. And then here we have the whole, we know the whole, so we're going to take that big number 123, take away 92, and it's going to give us this missing part. So we have 123 minus 92. So I think that will help you be successful with that one. So far we've talked about prime numbers, we've talked about the distributive property, we've talked about estimating and rounding, and we also talked a little bit about lines and angles and measurement. So focus on those, then we can worry about fractions a little bit later on. Thank you.